Hey guys, I thought that I would do a video of just a comparison of setup between a traditional analog timing wheel and a digital angle gauge, just so people can see the comparison, the differences involved, and how you would go through the numbers in centering or zeroing the wheel and the gauge in both cases. And as you can see, I have them basically fixed. I bolted on this bracket that I could mount this in front of the wheel, so that when we're doing our checks and looking at numbers, you kind of have a correlation between the digital and the analog, and you can see what's happening, right? So first we're going to do a setup. This is the same 361 build, which I am kind of dragging my feet on. I want to get this buttoned up so I can get into the whole modification series with this, but we're still here. So what I will do is bring you in and just show you quickly what I normally do for the wheel is I like to make sure I have a long enough piece of a pretty stiff wire that I use for my pointer. Reason being, it has some spring to it, right? And it doesn't deform as easy. So because of its length, you can bounce it by accident, or you can hit it and it kind of springs back, and it's a bit forgiving. And it's just mounted on one of the bar studs with a spacer, a nut spacer, and then the bar stud nut is tightened down over the wire to sandwich it, right? So that is the wire setup and where I mount it. Let me see here. So what I typically do is, first off, I visually eyeball top dead center just by, obviously spark plug hole is open and through the decomp, just eyeball top dead center where the piston plateaus at the top and doesn't move. Well, we're right about there. And then, actually let me show you, this is just a cheapo plastic chuck that you can buy, you probably find in most hardware stores. You know, it doesn't have to be anything special. But what I do is when I mount it, eyeball zero in the top dead center in the cylinder, and then line up your pointer with top dead center when you mount it, just so you're close enough. You know, you don't want to be fighting a whole trying to zero and balance between big numbers. I like to get as close as possible. And of course, an extension on the chuck would be nice, so that you have room between the case and the wheel. Right now I barely have about inch and a half, so it's a bit tight. It's a bit tight with my hand in here, but 2 fingers and you can snug up the chuck pretty good on the clutch side. So we're good there. Let me bring you around front. I think that's good enough to see the wheel. Should be good there. Right, so I want to give you a good visual. Alright, so what we're going to do is we will center using the wheel first, and then we will go to the digital gauge. So essentially what we're doing, now that we have eyeball center and we have our wheel pretty much, you know, TDC mark close to our pointer, we should be within, hopefully, 10 degrees. This is a little chart. Essentially, and again, I like to use solid piston stops, right? One of these guys. I just prefer to take the human error out of the process of stopping either way, you know, rather than eyeballing a skirt, say, through the intake and trying to get that repetitive every time. This to me is this works, and it's completely repetitive every single time. So I like to use that first off to create a positive stop that we're not second guessing ourselves. So essentially this is, let me come back, this is what we have. That's our wheel. You've got top dead center at the very top, 180 degrees is bottom dead center, and you're essentially creating a stop around top dead center. That's what your stop does. So when you, let's rotate this around to give clearance for the stop. Let's put this in. Snug it up. Right, so essentially what you're doing is you are creating a stop on either side of top dead center, and it looks something like this. Generally, most cylinders I've timed, I mean, depending on the bore, the degrees on either side of top dead center could range. I mean, it could be 50, 60, 70. It all depends, but I haven't seen any more than 90. So you essentially have a small sweep of time or measurement between on either side of top dead center, and you have a bigger sweep through bottom dead center, right? To me, it's easier to deal with smaller numbers, so we'll work with the sweep across top dead center to 0. So what we will do is we're trying to create equal distance between our stops, right? So we want this to be equal to that guy. Okay, that's what we're trying to do. So now that we have our stop in, we can rotate to stop, and we are at, all right, so this is going to be one side, so we are at, I'm reading 51.5, just about. And then if we rotate around to the other side of top dead center, I'm reading about 62.5. That's right, yep, 62.5. So we want to get to center, so we'll subtract the difference between the two, divide that number by 2, and just move ever so slightly, like physically move the wheel. And I have that bolt on the chuck. Snug, it's tight, but it allows me to rotate this wheel without the chuck slipping and moving, right? So 62.5 and 50. That's about 52. 52 and 62.5, so that's 10.5. So it's like 5 pretty much. So let us rotate this back 5. So that's about 62, 60, back 3 more, so that's 57. Right, so there we are, stop at 57. So we should be centered now. If we rotate back around, we should stop again at 57. Yep, that's it. Let me center you with the wire, so we are kind of take the parallax out of it. Just make sure we are seeing square. No, too close. Yeah, 57. 57. So we know that our wheel is now centered. Now if we had our wheel, we could take out our stop and start timing our cylinder. But what we're going to do is we're going to go through the process now with the digital gauge, and just use the wheel will be a reference to obviously double check and confirm the numbers that we're getting on this. So what we did with the wheel is we worked with this smaller sweep. Out of 360 degrees, we worked with this small sweep across top dead center and found the center point between the two to create two equal parts. And we did that by physically moving this wheel. Now, there's no physical moving with this gauge. It's all about zeroing and calculating where to hit zero to create that zero. So if we were to erase these numbers, well, equals, in actual fact we're at 57. So this is 57 and 57, both sides of top dead center, right? Which gives us a total measurement of 114. Correct? So that's 114 degrees in small sweep across top dead center. Now if we were to do, you can calculate it both ways. You can work with top dead center, or you can zero off of bottom dead center. And it's pretty much the same thing, and it's just that instead of your reference point being here and you're dealing with 57, your reference is here, and then you're dealing with what would that be, 123, right, degrees to make 180. So it's just how you measure it, right, and where your reference is. But I prefer to use the small side because it's easier to deal with these smaller numbers rather than these bigger numbers, right? So we know that we are 114 degrees across the small side from stop to stop. Now the physical movement, the physical moving of this wheel is actually the full sweep of this portion. You're starting from a stop and you're rotating this entire sweep all the way around to next stop, right? You're not actually rotating through the small side. But since we used the small side for the 114 degrees across top dead center, we're going to stick with that for the digital readout. So the process I use is, again, we're using stop. So right now we're at stop. Okay, so let's turn on. That's the actual degree measurement relative to level. So we're going to zero this out now. We're at stop. We are going to zero. And we are going to rotate all the way around to next stop. Now, first off, these gauges, they come in 90 degree and 180 degree versions, or have different features where you can measure directly from 0 right to 180, and then it counts backwards and goes back to 0. Or there are versions that are 90 degree by 4, so it'll go 0 to 90, count backwards to 0, then count up to 90, back to 0. You want one that reads 180 degrees. So this one is in 180 degree mode, and we can see it starts to count backwards when we rotate now to stop. We'll see it start to come backwards when it gets to 180. See, it's already starting. Let's go back. So 9, coming backwards. So we're going to go all the way to stop. That's stop. Now check out your reading. It's reading 114 degrees, which is the same distance that we measured with our wheel across top dead center, right? So with this, we've gone from here and zeroed and rotated all the way around past 180, and it counted downwards to this point, the next stop. So the number that is being shown here is what is left to get back to 0. In other words, to get back to this stop, which correlates with our 114 on the analog. So we know that that's the number that we're working with as the total distance between stops across top dead center. So we've established that the number we're working with is 114. So in order to get obviously the split between the two, we divide by 2. 114 divided by 2 is 57. So what we'll do from here is rotate back to, you can do it either way. You can work it from both stops. It's whether you're moving this direction or that direction with the 57 degrees. So we are back to stop, right? So what we will do, we know that that is 0. At this point now we can remove the piston stop from the cylinder and rotate now this until we read 57. So we're working our way back to 0. There we go. So what we've done is we established that from our 0 we need to move backwards 57 degrees to get to our true top dead center 0. And now that we're reading our 57, we can re-0. So we will hit our 0 button, and that will cancel the previous memory, and that 15.7 degrees is actual relative to true level. And then we will hit 0 again. Now remember this is important, 15.7. Let's write that down. And it's only important because this particular gauge does not have a memory function to keep your previous setting. So 15.7. So we hit 0, and that's it. That's top dead center right there, as confirmed. Look at that. That is pretty much spot on. Right? So we have confirmed both digitally and with the analog wheel how to time, well, not time, but 0 your timing wheel or gauge. Right? It's a fairly simple and straightforward process. If you were to do it from scratch, obviously I'm going through showing you what it is you're physically trying to do with this. So this whole process has, I mean, it's a fairly lengthy video, but if we had to do this from scratch, right, it would be pretty quick. So with that said, let me see. People will sometimes ask, well, what are the pros and cons? Remember this number, 15.7. If you set up a wheel, the pros to the wheel are that this wheel is fixed to your crank. This is fixed to your crankcase. Everything, unless you bounce this out of place or this slips on your crank, everything is fixed to your engine. You can pick this up and move it to a different surface. You can carry it outside, put it on a different table, you know, hold it at an angle, and nothing changes. The timing doesn't change. Your wheel hasn't shifted. Nothing has changed. But with the digital, you barely shift and move position of your saw on your table, on your bench, and you could be out by a few degrees, right? Is that it's fairly sensitive. So the pros of the wheel are that you know, it's kind of like a set it and forget it. If once you don't bounce it out of place, you can move this saw all around and it all stays true. It's all relative to one another. The cons are that it blocks the whole crankcase. It's kind of like you can't, if you have to pull your cylinder, check timing numbers, put in a ring and, you know, move it to set your ring to then go and grind and come back. Everything is in your way, you know. This is, it's kind of, it's not ideal, right? Which is where that's now the pro for the digital gauge, is that it's so small. When it's mounted, and imagine this not being here, you have a full view of the whole engine, the whole bottom half, crank. You can see everything. You can check your gasket if you're putting on gasket sealer or doing whatever. Everything is just easily visible and accessible, and you don't have to worry about something like this blocking you. But the con to using something like this is that you have to have your saw in the exact same position in this plane so that your numbers remain true, right? If you move it, you're going to be out of zero. So that is the only thing that sucks about that. So, but another thing too is if your gauge does not have a zero setting, a memory, that these all have auto shut off functions. So after, I don't know what it is, a minute, 2 minutes, this will shut off and I'm going to lose this zero. So essentially, let's get this back to zero. See, because I shifted this, it's off by a little bit. Oops. Trying to get it as close to zero as possible. Nope. Anyway, let's just assume that was back at zero. So we know that where this is zeroed is 15.7 degrees off of true level. So whenever this auto shuts off and you turn it back on, it reads true level. So once you know your measurement, if I take off memory, see, it's supposed to be 15.7, but we moved a bit, so 16. So if this auto shuts off, and let's just simulate that, so it's off, right? And I turn on, and let's say this got moved by accident. Everything, it got moved. I can rotate this around until I hit my 15.7. And I can zero. And I know I'm back to zero at top dead center, confirmed by the wheel, right? So that's a get around for if you're using a gauge that does not have a memory function. Some of them, when it shuts off and you turn it back on, it holds the previous zero setting, which is nice. That's a plus. I think maybe the Wixie ones, that Dino Joe sells, I believe they hold the zero. I'm not 100% sure, and other ones may, but this particular Klein Tools gauge had really good reviews online. It had the 180 degree function, and the only thing that sucks is it does not hold that zero. But again, once you know your reading relative to horizontal, and you can keep that written down, you know that if you don't move this saw and it stays in the same position, you can automatically find back zero without worrying about it.